Hello friends, myself R.D. Mahajan presenting my video on Euler's method. Second example, given dy by dx is equal to y minus x, condition y at 0 is equal to 2, initial condition. Then find y at 0.4 with h is equal to 0.1 by Euler's method. And therefore, to apply that Euler's method, here given differential equation is dy by dx is equal to y minus x. We call this as f of xy, and then condition is y at 0 is equal to 2. Y at 0 is equals to 2 means x0 is equals to 0 and the corresponding y0 is 2. And we consider h as 0.1. And when h is 0.1, x1 is given by x0 plus h. It is x0 is 0, h is 0.1. We get that value as 0.1. Then x2 is equal to x1 plus h. It is x1 is 0.1, h is 0.1. We get that value as 0.2. Then x3, we have to perform this calculation till we get that value of 0.4. And therefore x3 is x2 plus h. x2 is 0.2 plus h 0.1. We have the value as 0.3. And the last x4 is equal to x3 plus h. x3 is 0.3 plus 0.1. We get that value as 0.4. And by Euler's theorem we have yi plus 1 is equal to yi plus h into f of xi yi, with I is equal to 0, 1, 2, so on. And therefore, when we substitute the value of I is 0 here, we get that first solution y1 is equal to y0 plus h f of x0 y0. Then y1 nothing but y at x1. y0, the value of y0 is 2, h is 0.1, f of x0 y0, value of x0 is 0, corresponding y0 is 2. And therefore, we get that 2 plus 0.1, f of xy is nothing but y minus x, and therefore it is 2 minus 0, and we get that as 2 plus 0.1, 2 minus 0 is 2, therefore this is 2 plus 0.2, we get that value as 2.2. This is y at x1, but x1 is nothing but 0.1, and therefore y at 0.1 we get as 2.2. Then we put I is equal to 1 in this formula. We get second, that is y2 is equal to I is 1, therefore y1 plus h f of x1 y1 for I is equal to 1. And then substituting the values, corresponding values, we get y1 is 2.2, h is 0.1, f of x1 is 0.1, and the corresponding y1 is 2.2, and therefore it is 2.2, 0.1, f of xy, once again it is y minus x, and therefore applying that we have 2.2 minus 0.1, we get 2.2, 0.1, 2.2 minus 0.1, we get that value as 2.1. And then simplifying by calculator, we have 2.41. Y2 means y at x2 and x2 is 0.2. Therefore, this is the value of y at 0.2. Then we put I is equal to 2 to get the next value. For I is equal to 2, we have 2 plus 1, that is y3 is equal to y2 plus h f of x2 y2. Then substituting value of y2 is 2.41, h is 0.1, f of x2 y2, x2 is 0.2 and y2 corresponding is 2.41. It is 2.41 plus 0.1 x y minus x. Therefore, it is 2.41 minus 0.2. 0.41 minus 0.2, we have 2.21 into 0.1 plus 2.41. By calculator, we have 2.631 is the value of y3 nothing but y at x3, and it is y at 0.3. Put I is equal to 3 in this formula of Euler's method. We have y4 is equal to y3 plus h f of x3 y3, and that is equals to corresponding y3 is 2.631 plus h 0.1 f of x3 y3. Value of x3 is 0.3 and corresponding y3 is 2.631. 2.631, and we have 2.631 plus 0.1. F of xy is y minus x. Therefore, 2.631 minus 0.3, that value is 2.331. 2.331. It by 0.1 and adding with 2.631, we have y4 nothing but y at x4. x4 is 0.4 and 2.864. Is the required solution of that given differential equation by applying Euler's method. Therefore, we have y at 0.4 as 2.864. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.